An aircraft flight control system is a crucial component of an aircraft that allows the pilot to control its movement and maintain stability during flight. It consists of various mechanisms and devices that work together to manipulate the flight surfaces and control the aircraft's attitude, altitude, and direction. The primary flight control surfaces of an aircraft include ailerons. These are located on the wings and control the roll motion of the aircraft by moving in opposite directions. When one aileron moves up, the other moves down, causing the aircraft to bank left or right. Elevators. Located on the tail section, elevators control the pitch motion of the aircraft. They move in opposite directions to adjust the aircraft's nose up or down, influencing its altitude. Rudder. Positioned on the vertical stabilizer at the tail, the rudder controls the yaw motion of the aircraft. By moving the rudder left or right, the pilot can change the aircraft's direction around its vertical axis. In addition to these primary control surfaces, modern aircraft also employ secondary control systems and mechanisms that enhance flight control and stability. Flaps. Flaps are located on the wings and can be extended or retracted to increase lift during takeoff and landing, allowing the aircraft to fly at lower speeds. Spoilers. Spoilers are deployed on the wings to disrupt the smooth airflow over the wings, reducing lift. They assist in reducing speed, initiating descent, and improving the aircraft's descent rate during landing. Trim systems. Trim systems enable the pilot to balance control forces and reduce the need for constant control input. They adjust the control surfaces to maintain the desired aircraft attitude without continuous pressure on the controls. Fly-by-wire (FBW) system. Many modern aircraft use a fly-by-wire system, where electronic signals replace traditional mechanical linkages. In FBW systems, control inputs from the pilot are transmitted as electronic signals to computers that interpret and send corresponding commands to the control surfaces. Control surfaces. The control surfaces, such as ailerons, elevators, and rudder, are movable surfaces on the wings and tail of the aircraft. They change the aerodynamic forces acting on the aircraft, enabling control of its roll, pitch, and yaw movements. Actuators. Actuators are mechanical or hydraulic devices that convert electrical or hydraulic signals into physical motion. They are responsible for moving the control surfaces based on inputs received from the pilot or the autopilot system. Sensors. Sensors play a crucial role in the flight control system by providing real-time information about the aircraft's state, such as its attitude, altitude, airspeed, and acceleration. These sensors include gyroscopes, accelerometers, pitot tubes, air data computers, and inertial navigation systems. Flight control computers. Flight control computers receive inputs from the pilot, sensors, and autopilot system, process the data, and generate control commands to the actuators. They employ complex algorithms and control laws to interpret the pilot's inputs and ensure the desired aircraft response. Autopilot system. Many aircraft are equipped with an autopilot system that can assume control of the aircraft's flight based on pre-programmed instructions or inputs from the pilot. The autopilot system interfaces with the flight control system to issue commands and adjust control surfaces as needed. Fly-by-wire (FBW) system. In modern aircraft, fly-by-wire technology is often employed. It replaces conventional mechanical control systems with an electronic interface. In a fly-by-wire system, control inputs from the pilot are transmitted as electrical signals to the flight control computers, which then determine the appropriate control surface movements. Redundancy and safety. Flight control systems incorporate redundancy to ensure safety and reliability. Critical components, such as sensors, actuators, and computers, are often duplicated or triplicated to provide backup in the event of a failure. These control systems are typically interconnected and backed up by redundant components to ensure safety and reliability during flight. They work in tandem with other onboard systems, such as sensors, computers, and autopilot functions, to provide precise and efficient control over the aircraft's flight parameters.